Hi everyone, let's see how to solve this exponential equation, which, as we're about to see, involves a hidden quadratic. So let's go ahead. We're told solve for x, and here's the equation. 3 times 2 to the power of 2x plus 12, which equals to 15 times 2 to the power of x. Now if you're up for it, go ahead and press pause and try solving this on your own. Either way though, let's get started. Okay, as I always do, I'll start by writing SOL for solution. Now, looking at this equation, it's quite clear that we're dealing with an exponential equation. Indeed, the unknown x appears as an exponent on this term here, this 2 to the power of 2x, and on this term here, this 2 to the power of x. And a very important thing to pick up on here is the fact that this 2 to the power of 2x is nothing more than 2 to the power of x squared. And in fact, I'll write that down. It's important to realize that 2 to the power of 2x is equal to 2 to the power of x squared. Indeed, we know from our laws of exponents that if we raise this 2 to the power of x to the power of 2, this 2 comes and multiplies the x we have here. Now, with this in mind, we can go ahead and rewrite the equation we have here as 3 times 2 to the power of x squared plus 12, which equals to 15 times 2 to the power of x. Looking at the equation we now have, you may see that what we're dealing with here is a quadratic in 2 to the power of x. But what I like to do is make that more obvious. And for that, I go ahead and define a new variable. And here's what I mean. I'll go ahead and say let capital X equal to 2 raised to the power of x. And just to be clear, this capital X is a new variable. It's not the same as the lowercase x that we're trying to find. But so now, with this new variable, capital X, I'll go ahead and rewrite the equation we have here, but I'll replace each of the 2 to the power of x's that we see by capital X. And in doing so, this equation turns into 3 times capital X squared plus 12, which equals to 15 times capital X. And although we don't have to change the variable this way, indeed, if you prefer working with this equation, by all means do so, I quite like doing this because it allows me to at least temporarily step away from the exponential equation and focus solely on this quadratic equation. So I'll go ahead and solve this equation. Gathering all the terms of this equation on the left-hand side, this becomes 3 capital X squared minus 15 capital X plus 12 equals to 0. And looking at this equation, it's clear that we're faced with a standard quadratic equation. So let's go ahead and solve it, and I'll do that up here. And I'll quickly copy that. That's 3 capital X squared minus 15 capital X plus 12 equals to 0. Now to solve this, we could use the quadratic formula, or we could try and solve it by factoring, and I'll go ahead and do that. Looking at all the terms we have here, we can see that all 3 of the coefficients have a common factor of 3. So I'll go ahead and take that factor out. That's 3 times, in parentheses, capital X squared minus 5 capital X plus 4, close parentheses, equals to 0. I'll now factor the quadratic we have inside this pair of parentheses, x squared minus 5x plus 4. And to do that, well, I'm looking for 2 numbers whose sum is negative 5 and whose product is 4. And it doesn't take too long to see that negative 1 and negative 4 work. Indeed, negative 1 plus negative 4 is negative 5, and negative 1 times negative 4, well, that's positive 4. So with those 2 values in mind, I can go ahead and write this in factored form as 3 times, in parentheses, capital X minus 1 times capital X minus 4. And all of that must equal to 0. Okay, now looking at this product of factors, since it has to equal to 0, that means that either 3 equals to 0, which clearly isn't the case, or that capital X minus 1 equals 0. And I'll go ahead and write that. One possibility is that capital X minus 1 equals to 0. Which would mean that capital X equals to 1. Another possibility for this product to equal to 0 is for this capital X minus 4 to equal to 0. So if capital X minus 4 equals to 0, that would mean that capital X equals to 4. And as such, we've now solved this quadratic equation for capital X. But we're not done. Remember, the capital X that we see here is equal to 2 to the power of x. In fact, I'll go ahead and box that. Remember, capital X is equal to 2 to the power of lowercase x. Consequently, we can rewrite both of these results as 2 to the power of x equals to 1 and 2 to the power of x equals to 4. And so solving each of these two equations, 2 to the power of x equals to 1 is the same thing as 2 to the power of x equals to 2 to the power of 0. Remember, any non-zero number raised to the power of 0 is equal to 1. And so if 2 to the power of x equals to 2 to the power of 0, that tells us that x must equal to 0. And so x equals to 0 is one of the solutions to the exponential equation we started off with. Now, looking at the second equation we have here, 2 to the power of x, which equals to 4, if we write the right-hand side as a power of 2, it becomes 2 to the power of x is equal to 2 raised to the power of 2. And so for 2 to the power of x to equal to 2 to the power of 2, we can state that x must equal to 2. And that's the second solution to this exponential equation. And if you want to check that both of these are indeed solutions to this equation, you could go ahead and replace every x you see by 0, and you'll find that the left-hand side is equal to the right-hand side, and then of course you could replace every x you see by 2, and once more you'll find that the left-hand side is equal to the right-hand side. And there we go. That's how we can solve this exponential equation involving a hidden quadratic. All that being said and done, that's it for this tutorial.